Hi, everyone. Welcome to this talk on improving AI benchmarks. This is about making AI work in the real world. Right? It's great to be here. And before we start, quick show of hands to get a sense of what the research interests of folks in the audience are at. Who's working on making AI better for coding? Group. Okay. A couple of folks. Math. Training agents that can actually get things done in the real world? Great. A lot more agents. Sounds good. Great. So let's get started. Firstly, a little bit about me. I'm Jonathan Siddharth, founder and CEO of Turing. I'm an AI researcher turned entrepreneur. My background was primarily in search and machine learning based algorithms for improving ranking. So working on text classification, text categorization, back in the era of supervised machine learning, when people cared about feature engineering and picking the right algorithm and stuff, it wasn't always use a deep neural network or always use a transformer. I received the best master's thesis award in computer science at Stanford, and I've also published a few papers. So my company Turing works on accelerating AI advancement and deployment, and we do this today in two ways. First, we work on training frontier models. So we work with all the leading labs, OpenAI, Anthropic, Meta, Google, Microsoft, to help the models get better at coding, math, STEM, advanced reasoning, agents, etc., by generating really high quality training data. But then we also build AI applications for large enterprises in banking, financial services, etc., which gives us a unique vantage point to see what the current state of the art in these models is like, where do the models work well and where do they break. And so we do this by using our talent cloud. So we have about 4 million plus software engineers vetted in a wide variety of roles, tech stacks, and seniority levels. And we have these PhDs in physics, chemistry, math, biology, professionals in marketing, finance, etc., that work on our platform to generate data. And they're generating data for supervised fine-tuning, reinforcement learning, to do evals, which again gives us this vantage point on where the models are today in terms of their level of performance and what's needed to take things to the next level. Today, the AI labs work with us in a wide variety of areas. Usually it starts with diagnosing where a model's weaknesses are, whether it's with coding, with math, with multimodality, etc. Diagnosing weaknesses and then figuring out how do you generate data to help the models get better in those very specific areas. So usually it's a combination of evals, SFT, running targeted RLHF loops, and more recently, it's a lot of data generated for training reinforcement learning based models. So that's what we do at Turing. And for today's talk, we're going to cover a few things. We're going to first look at the current state of benchmarks, where today's benchmarks have limitations, and I'm going to share our approach and our methodology to get better at these benchmarks, right? And I'm going to also call out some areas where we'd like to collaborate with the research community. If you're working in research on benchmarks or in any of these areas, we also have some research internships, so you should come talk to us afterwards. So let's start with the obvious truth, right? You improve what you measure. Benchmarks today aren't just diagnostics. They are guiding research on where developments should go next and gives us a way to accelerate model improvements. Benchmarks also shape where we choose to invest, right? So benchmarks really matter, and really good benchmarks can bridge the gap between research and reality. I personally like benchmarks because they help us figure out what's unsolved on the road to AGI. So today's landscape is is very complicated. Traditional benchmarks for coding, math are fast getting saturated. There are lots of newer benchmarks that push into deeper capabilities like tool use, long context, safety, etc. And the pace of expansion sometimes makes it really hard to track and evaluate things meaningfully. So we're going to focus on a targeted subset of this, specifically coding and multimodality, and the same approach sort of generalizes to a few of these other benchmarks as well. And I'm curious among this group, how many of you are kind of surprised that whenever there's a new model, it suddenly goes to like number one in the benchmarks? Surprised, right? Yeah. And it's all part of this broader issue, right? Now, benchmarks, when done well, actually accelerate model improvement. So the typical innovation loop is that we as a community first define a really hard challenge. 2 years ago, for coding, it was fixing a real GitHub issue, right? It could be solving a multi-hop science question or interpreting a really complex schematic. So we define a really hard problem, and then when we measure the models against it, some common failure modes get exposed, right? And the first attempts shine a spotlight on some of these failure modes, whether it's hallucinations, tool-free failures, fragile reasoning, or poor cross-model generalization. And once we've identified these failure modes, the research community jumps in, and researchers respond with different ways to address those failure modes, whether it's agent scaffolding, reasoning-aware fine-tuning, tool use, prompt engineering, and a variety of other approaches. And then we start seeing the payoff. Last year in SWE-bench, we went from 2% to 50%. GPQA, which is for STEM, which is a benchmark for STEM, rose from 28% to 59%. GSM-8K, which measures reasoning in like simple word problems with like multi-step mathematical reasoning, went from like 18% to 90% with better reasoning support, right? And once the models get better, we then start to see products built on top of these models. Like now, these are ready to ship into the real world. So the gains just don't just stay inside the research lab; they actually go into the real world, and they power real world tools, like whether it's coding copilots, interpretable math solvers, enterprise assistants, and many more. And then the benchmark starts getting saturated, and then we need harder benchmarks to power the next loop in this diagram. So benchmarks have been crucial. They've not just revealed what's hard, they've driven the playbook for how we iterate. It's a combination of iterate, innovate, integrate, and evolve. Now, today's benchmarks do have some limitations. As many of you know, some of those limitations are benchmark saturation. They don't reflect real-world utility. There's data leakage. Sometimes there's formatting biases. Static benchmarks come with their own issues. And sometimes there's a lack of repeatability in evaluation results. We're going to go through these, and then I'm going to share our approach for some of the things that we're doing to overcome these issues. So first, there's the issue of these benchmarks getting saturated. I mean, last year we went from 2% to 50% in SWE-bench. It's widely believed that this year we'll probably saturate SWE-bench. And then we miss out on how to shape the next era of getting better at coding. Right? Today in MMLU, GPT-4o scores almost 87%, right? Like, or getting close to like 90%. And the other models are pretty close behind. At this point, does a 1% jump in performance really measure anything useful? Probably not, right? And many of these benchmarks are also struggling to distinguish what matters in terms of real progress. The GSM-8K, which was the middle school, like basically problems that a smart 11-year-old would be able to answer, word problems in mathematics, that's basically done. Like these models have basically solved that. And many of these benchmarks often don't reflect real-world utility. So this is a fun one. So this is from an actual benchmark. The question was, how many ducks in this image are pointing in the southwest direction when you look at it with like a 8-degree compass, like that measures 8 different directions. Now, I don't know about you all, but if I'm at a pond and looking at some ducks, that's not the question I'm asking, right? I'm probably like wondering something more. Maybe I'm wondering what breed of ducks are these, like given the ducks are from Northern California, where I'm from, or maybe you might be curious about maybe they're like what's the lifespan of a duck or something like that. So many of these benchmarks don't really reflect real world utility anymore. They don't track things that a real user interacting with the model would actually ask. And this becomes extremely relevant when you're using the models to do real work in the enterprise. If you're working in insurance and if you're working on underwriting or claims processing, you would want something that actually captures that real world use, right? Some of the benchmarks today like feel a little bit more like a singularity test, like have we achieved AGI or not? Is Skynet around the corner or not? But I feel like there's a lot more utility in like measuring whether the benchmarks are helping real humans do real work in an actual enterprise setting, right? And some of the benchmarks test isolated skills and not really whether you can complete an entire workflow. Right? There are some good efforts focused on creating benchmarks for real-world applications. MegaBench is a good one on scaling multimodal evaluation for over 500 real-world tasks. We need benchmarks that can also track multi-turn, tool-augmented, context-heavy tasks that require the models to apply their contextual knowledge to synthesize practically valuable and actionable outputs, right, which can be used for decision making. Today, there are very few such multimodal or agentic benchmarks that requires the models to combine contextual information across multiple modalities or even from different segments of the same modality. Example, sometimes you might want to reason using data from multiple charts to answer a question, right? Some of the benchmarks that are quite good, like SWE-bench for measuring real-world software engineering, tends to focus more on bug fixes of a few lines. A lot of the data in SWE-bench, like the edits are less than 7 lines. And they tend to focus a lot more on bug fixes and new feature additions. And other types of software engineering tasks are less well represented. Obviously, SWE-bench does not measure things like code quality, whether there are security vulnerabilities, whether your coding style matches the rest of the code base, whether you've written maintainable code, like all of those real world engineering considerations are not captured, right? They're out of scope. And limitation number 3 is data leakage and contamination. Eval sets frequently leak into these massive training sets like C4 and the pile. And even with n-gram filtering, it's nearly impossible to prevent overlap at a trillion token scale, right? So when a model gets the right answer, sometimes it might just be remembering things and not reasoning, which can inflate scores and gives us a false sense of capability because the models haven't truly generalized. And this could also be an issue with benchmarks like SWE-bench, which are also like open source GitHub repos. There's also the issue of formatting and positioning. So there have been some results that showed like why the ABCD format is very brittle and there's a formatting bias. Oftentimes, like the models will guess C or all of the above, and when they guess that, they tend to do quite well. This paper showed that just flipping the positions like dramatically changed the performance of the different models, which again shows some level of overfitting. And to get against it, you might have to shuffle the order of the questions multiple times. You might have to flip it around, which then increases the cost to actually evaluate these models. And the ABCD type stuff also doesn't work in a lot of real world tasks, which are rarely that binary. Like often Like, I mean, you might care about the chain of thought reasoning. You might care about partial credit. You might care about other nuanced explanations that are not captured by this style of benchmarking. Right? And there are a lot of like open-ended enterprise workflows, like where this type of method will not work. Imagine an SDR, a sales development representative, who's doing prospecting of a client before reaching out to them, right? Like what would be the benchmark for that? Like these types of benchmarks don't capture that. How well this human did research, or how well did the model assist the human in doing research ahead of a sales call? So those things don't get captured. So the general theme is the benchmarks are not complex enough and they don't capture real world workflows as deeply enough. Static benchmarks also quickly become outdated, right? In the real world, things change. There are new discoveries in science, medicine all the time. The answers might become irrelevant or inaccurate, right? Which is a problem. Sometimes different research groups will also need access to different versions of a benchmark. Maybe one research lab that is really farther ahead in coding might want the most advanced version of the coding benchmark. Whereas for a research lab that's still earlier on in their journey, it might help to have earlier versions of that benchmark available so they actually have a gradient for how they are improving. This is why newer benchmarks like LiveBench and LiveSweetBench have started versioning datasets, and I encourage you to check those out. The sixth limitation we see is the lack of repeatability in evaluation results, right? And LLMs, the LLMs arena, the chatbot arena work is really cool, and I'm a big fan of it. But obviously, those types of benchmarks also come with their issues. The people on chatbot arena are often hobbyists, researchers that are like checking out the latest models. And it might not really reflect how a real human uses these models in practice to do real work. Today at Turing, we work with banking, financial services, insurance customers. We build AI solutions for them on top of these models. And I can promise you, they're not using Chatbot Arena to check how well the models do at claims processing or underwriting or customer support, right? So it's somewhat of a skewed audience. And there's also this bias of this chat interface, right? In many of these cases, the models are going to be used via an API, not necessarily a chat interface. And you don't want to optimize for like what models really do well in a chat interface. You probably care about like an API that's integrated into an application or like powering an agent. My co-founder like shared this with me. Like the chat interface often is like the tail wagging the dog sometimes, and we don't want that. Right? In the words of Turing's head of R&D, if the benchmark you need doesn't exist, you just have to create it, right? And I hope all of you create more realistic, more complex benchmarks. Please do. Let's give the academic community and the research community more real-world hills to climb. And if you want to collaborate with us on our work to create really hard, complex benchmarks that match real-world usage, come talk to us afterwards. After the talk, we'll be standing by the door. This is not hypothetical. This moment actually happened during one of our all-hands meetings, where we just decided we're going to create like these really hard, really realistic benchmarks. And we asked ourselves, like, what would make for a really useful benchmark, right? Step one is it has to be rooted in real-world use cases. No more counting ducks in a pond or which direction the ducks are pointing at, right? Let's really check whether the benchmarks are measuring useful stuff. And the benchmarks have to be challenging, where they should break all the models today. They should break the models, and they should break agents that have the models, that are calling the models in an inner loop. They should break both. Right? You want things to be scalable and automatable. You want to be able to evaluate things really, really quickly. You want reproducible results. And the benchmarks have to be trusted. Right? So it has to be a collaborative effort across labs, across industry, across academia. And that's Turing's motivation in working on these applied AGI benchmarks. We don't think we can do it by ourselves. We need help from you all as well. Why this matters is if we do this right, developers will now be able to track regressions really well. When they're launching a new version of a model, they could check it against this benchmark and see how well they do. Second, enterprises could choose the right model to deploy based on these much more realistic benchmarks. Wouldn't it be awesome if there was a benchmark for banking for assessing, let's say, credit risk, or a benchmark in insurance for underwriting and claims processing, or a benchmark for assessing the performance of a sales rep or a customer support person, right? And finally, it gives the research labs, the frontier labs, a more realistic hill to climb. So we keep improving the models in a direction that will actually help humanity today and move the GDP of the world. So we are focused on fixing this in a few different ways. There are a few aspects of our approach to improving on these benchmarks. The first is to focus on model breaking evaluations. So we've already created a data set that's harder than SweBench that breaks all the models and breaks all the agents. It's particularly satisfying when you can get all the frontier models down to 0%. And we did a lot of work to make sure that, for at least 6 months, the benchmarks kind of hold. And I'll talk a little bit about what we did there. We want these evaluations to be focused on real world use cases, questions that a real human is likely to ask in that context versus these contrived examples. We are also we are building the capability to do private evals so that if you're building a model, you could use us to privately evaluate your model so there's no risk of data contamination or data leakage. No more multiple choice. We want to design a more robust framework that rewards more open-ended problem solving. And we're also creating version benchmarks, right, to make sure that we can keep updating these benchmarks over time, and the community could choose which version to use depending on where they are in their hill climbing journey. The goal is to not just measure AI's ability to pass the test, but it's to measure whether AI can actually do the work. Today, a lot of our benchmarks feel like we can pass the bar exam, but can't really do the work of a lawyer. You can pass a coding interview, but can't really do the job of a software engineer, even an intern, right? So it's we want to measure real world use, and see if whether we can actually create complete business critical workflows. Here's an example of one of these real-world examples that we are covering in our finance benchmark. This is an applied AGI benchmark for finance. And in this benchmark, imagine a finance manager that's looking at two graphs. The first graph shows revenue growth by sector for a business that includes these 4 lines. You may not be able to see it. It's leather, pharma, and 2 others. The first shows revenue growth. The second graph shows revenues, right? And I'll call your attention to the second graph, where if you look at the year 2011, the revenue numbers are not explicitly marked. They're blank. It's listed for 2010, but 2011 is not listed, right? Now imagine a financial analyst that has to calculate what is the total revenue for 2011, right? Now, a normal human analyst would look at what was the revenue last year, which you can get from the bottom chart. It's explicitly marked. You can sum those up. And then you can look at the growth rate from the chart above and combine the two to reason, right? You're reasoning based on 2 different images. But none of the state-of-the-art models did that. The state-of-the-art models tried to approximate based just on the second image alone. They didn't use information from the first image to calculate what the revenues would be in 2011. And that's a very brutal sort of way to calculate it, right? Imagine if a human drew this on a whiteboard, the scale and axis, all of it would be off. So that's an example of that's the approach that we take when we create these benchmarks. They have to break all the models, and it has to be a question that a real human doing that work is likely to ask, right? So you can imagine all sorts of this type of reasoning that an FP&A, a financial planning and analysis person might ask, an investment analyst might ask when they're figuring out which stock to invest in, or a venture capitalist might look at a management information systems and MIS dashboard to figure out like which company to invest in. So we want all of this to work. Right? And in coding, and this is one of my personal favorites, at Turing we do a lot of work on coding. Like we have the world's largest developer cloud with 4 million software engineers, and we really want these models to get good at coding. Right? SWE-bench is a really great benchmark, but as I mentioned, we're about to saturate it. So we are building a harder than SWE-bench benchmark, and we're doing that in a few different ways. First, SWE-bench, as you know, is primarily Python. It includes libraries like matplotlib, scikit-learn, some of these open source Python repos. So we broadened it to go beyond Python to JavaScript, C, C++, etc. We had to build a Dockerized container to execute code in C, C++ when we are doing these evaluations. We did this in a way that, the way SWE-bench works is you take a repo, you take a prompt, and the prompt is usually an issue. And in GitHub, an issue is a pull request that gets merged. It could be a bug fix. It could be a feature request. And then you check if test cases pass, right? So we picked other programming languages, JavaScript, C, C++, in addition to Python. We also noticed that SWE-bench's issue distribution tended to focus a lot more on bug fixes and relatively small bug fixes and some new features. But there are lots of other types of issues in GitHub, right? Like including documentation, including more complex code refactors, plugging security loopholes. So we made sure that the issue coverage was a lot broader and reflected real-world software engineering. We made sure all the models failed. We picked hard enough problems that the current state-of-the-art models and agents would break. Right? Today, Augment Code, Cursor are some of the top agents. We made sure that this would break those models as well. Augment Code is also a customer of Turing, so we like them, but we like breaking all of the models. They're all our customers, but we think that's the way we can help them. So we broke all of the models. And in SWE-bench, there is this thing where most of the edits are like less than 7 lines, right? So we picked like problems where like the issue required like 1,000 lines to be edited in one particular example. Not all of them, but in one particular example. So we're picking more complex patches, right? So we have this really interesting data set now. And again, if you're interested in looking at this data, come talk to us afterwards, and I can share like some samples of like what this looks like. But this is again to help everyone in AI research improve coding in a world where SWE-bench gets saturated this year, right? So we are picking problems that are harder and more generalizable by picking underrepresented categories of issues in SWE-bench, underrepresented languages as well. And in summary, there are all of these different issues that we focused on that we have at Turing today. If you're working on any of these domain-specific benchmarks in banking, financial services, insurance, etc., or you're working on benchmarks that are really hard and reflect real-world coding, math, multimodal reasoning, come talk to us. We really want to do this in a collaborative way with the rest of the community. So if you're interested in working together on these benchmarks as well, we'd love to talk to you. If you're training agents on real-world business cases that automate knowledge work in business for a variety of different roles, for a variety of different workflows in different industries, talk to us. And my email is johnsid@turing.com. We also have research internships at Turing, like for folks working in some of these areas that are of relevance to us. So that would also be fun to chat with you about. Thank you, everyone, and it was great to chat with all of you. And I'll take 5 minutes for a few questions, and then I'll wrap up.
You can raise your hand if you have a question.
So, Jonathan, thank you. I'm Helen. I'm running a family office here in Singapore. I appreciate this talk. I think this is crucial, very important. But as you mentioned that what you're trying to develop benchmark is around real world use cases, right? And so I'm curious how at Turing that you accumulate the knowledge, because unless you have, especially in an enterprise setting, not a consumer application, enterprise setting, you do need the enterprise domain in every specific vertical sectors, right? So in order to really test and create the right benchmark, you absolutely need the industry depth knowledge to do that. And you're a technology company, and I met with David a year ago, and most people are engineers. So how do they accumulate the knowledge and create a benchmark to test? Thank you.
Thank you, Ms. Great question. So how do we accumulate that knowledge? So we do that in two ways. Step one is we hire domain experts that are actually doing these workflows. For example, we've hired people from healthcare, from insurance, from finance, from marketing. The way I think about it is like a three-dimensional matrix with pick an industry, banking, financial services, retail, healthcare, etc. That's the first dimension. The second dimension is pick a function, sales, marketing, software engineering, product management, etc. The third dimension is in that function, let's say we pick marketing, there are different roles in marketing. There is maybe director of performance marketing, there is content marketing, there is SEO marketing analyst. That's the third dimension. Actually, we'll add another dimension. Then there is a specific workflow that a human might take, right? A director of performance marketing might have a workflow where they have to evaluate different marketing channels to figure out what's delivering good ROI for the business, and then make a decision on where to invest more, right? So think of this four-dimensional matrix: industry, function, role, and a workflow, right? 4 dimensions. Now that's $30 trillion of knowledge work, if you unpack that, right? That's what we have. So we pick humans in this 4-dimensional space. I feel like this is the only audience in which I can talk like this. Normally I don't. But so we pick a human that actually does this work. Imagine a sales rep that is selling into healthcare that has this workflow of prospecting, right? We hire these domain experts on Turing, sometimes part-time on a gig basis to do this particular task. And we build an environment for them to work inside of, where they can generate that data. Today, one of the things that we are, that there's a lot of talk about is in reinforcement learning, you probably want to build like a world model that's a digital twin of their real world business environment, like a business world model, right? You want to have that world model inside which an agent could be tested, where the agent is like doing that workflow, calling other APIs, using tools, operating a computer, and this domain expert gives feedback to the model. The domain expert might help the agent in a long horizon RL task, see whether the agent is taking steps in the right direction. So how do we do this at Turing? It's a combination of having the right domain experts and building software where this domain expert inside that simulated environment can then generate data that's useful. So you need both. You cannot do it as just engineers. That's why out of our 4 million pool, we've now started hiring PhDs in physics, chemistry, math, biology. We have somebody who's an expert in dark matter. We have like people in sales, marketing, finance. You need those human experts. I think the next phase of AI progress is going to happen by these models observing how real humans do real work, and then figuring out where things break. And when things break, it creates data either for training the next generation of models or giving us benchmarks.
Hello, I'm Martin. I'm from Denmark, Aarhus University. And I was just wondering, I think a lot of us in this room are academics, and to a certain extent, most of us have some commitment to open data and openness in general. Do you think that there's absolutely no way around making benchmarks private that would prevent, model makers from overfitting on them?
No, I don't think there's a way to guarantee it. Even in these in a private evals model, they'll there's some level of shaping the direction that's going to happen just by. I think private evals they're significantly better than public benchmarks for preventing overfitting. I'm curious, like you said, so as an academic, like you were interested in this. What do you feel would be more useful for like your type of for the kinds of research that you work on?
Well, I mean, I'm not completely close to the idea of private benchmarks. I just don't like it. So that's why I wanted to ask you, because I can see how that would work, but it would also be nice if, we could have the cake and eat it too, if you know what I mean.
Yes. I mean, it's one of those things like, I think private benchmarks, in my view, are okay if it's done by a third party that's not the model builder. And ideally, that's working across the board with everybody. And and when we release private benchmarks, like we should probably like publish a paper alongside it describing our methodology for how we are doing it, and partner with researchers in academia and in the industry to do that. I agree with you that there's something about private. Maybe it's not that great for open research, but perhaps the middle ground could be us exposing our methods for how we are doing these evals. The thing that I feel is worse is when these data sets get leaked and now the tests don't really mean anything because the models have overfit and memorized the results. I feel like that's worse.
Hi, this is Vivek here. I wanted to ask, like, are you all up to any efforts related to multilingual and multicultural data sets, like, say, a task A works for language A, but not for language B? And similarly, for multicultural settings, like different things mean differently in different languages and in different cultural settings. So do you all know what's SOTA over there?
So yes, multilinguality and multicultural performance is extremely important. Like we see a lot of interest in that. And there are also interesting lessons in terms of how well the models transfer learning when it's different pairs of languages. There is some research I can follow up offline. There are some pairs of languages that are very contrastive, where like you actually learn a lot more when it's this set of languages. So it's like multilinguality is really, really important. And we do a lot of SFT, RLHF, evals work on multilinguality for a wide variety of languages. We've done a lot for Indian languages, Korean, Japanese, French.
Like how does this data set look like? Are there like different tasks same tasks in different languages, or can you give some example on how does these data sets look like?
So usually it all starts with what's the research objective of that particular lab, and maybe the research objective is helping the model get better at math when all the tokens are in Hindi, for example, right? Like then there's some numbers, but lots of Hindi, and you want the model to get better. So we would usually start by creating a taxonomy, and the taxonomy might be at various levels of granularity. And then we evaluate the models at the leaf nodes of the taxonomy, and we see where they are. And step one might be a side-by-side eval of every model against every model it's competing against, and see where the gaps are. And then usually we start with supervised fine-tuning, which is very costly, but usually like will give the best signal. And then we might do another round of evals to see if the models got better. And once they get reasonably better, then switch to RLHF to get the next round of signal. So it's the same approach, but again, much like you need a combination of humans and tooling. The humans now are humans who are experts in these different languages, and you want the tools to also be designed in a way that the human time is optimally used. Do things in AI as much as possible, like use synthetic data whenever you can, so that there is usually an AI upstream of the human that's generating V1 of the data, the human edits the data, and then there's another LLM as a judge doing quality control on the data that's generated. And one other interesting thing which Sudarshan, who heads our AGI advancement business unit, had an interesting observation at NeurIPS last year, which is the interesting stuff with today's tasks is that it requires a composition of different skill sets. For example, if you're testing like a new theory in physics, maybe you have a prompt for like a new theory in physics that you want to test. This might involve writing code for a simulation and then maybe writing the simulator itself and then analyzing the results from that simulation. This might require skills of an expert human physicist, a really strong software engineer, and a really strong data scientist. Oftentimes, these skill sets may not even occur in the same human. So the data that you generate, there's a part of it that's generated by a physics expert, a part of it that's generated by a software engineer, a part of it that's generated by a data scientist, which I think is kind of neat. Like we all talk about whether the models can exceed human performance. Today, the models are not just in some cases beating a single human, they're beating a panel of the smartest humans, right? Which I think is kind of cool. Cool or scary, whichever way you think about it. I prefer cool.
Hi, I'm Milan, coming from Everseen Limited, so from the industry. I have just one question, which is, you're mentioning overall that you are hiring a domain expert, so you are probably hiring one or a couple of bankers or doesn't matter, directors or so, but just with all of this approach, with the single benchmarking data sets that are now private or so, without any kind of automation, I don't know if we are going towards generalization across the field, or you are heavily having some, again, specialized model that might not, specialized benchmark that might not, again, reflect the behavior in the wild. I'm a bit afraid that we might need to go towards automation, or again, I'm not sure if the private is the way to go, in a sense that a bunch of people in the industry might want to try this and also record it and be able to benchmark it on their own in the future. So I feel like it might be a future rather than a private single, recorded somewhere benchmarks for the, I see this as only a beginning. Can you comment on my sort of idea?
Yeah, I mean, we should chat more after the talk, but you're right that it's just the beginning. And I would also say, I mean, if your concern is, hey, you're hiring some of these experts in banking and financial services and medicine, are we truly generalizing? Or if that's your concern, I would say those are two independent problems. The motivation to create the benchmark is not necessarily to check whether one model can solve them all. We actually don't care. It's possible that maybe a top lab has one model for banking, one model for financial services, one model for healthcare. That's okay. We just want the benchmark to reflect real work done by real humans, and it's complex enough so that whichever approach you take, maybe one lab solves it with one model to rule them all. Another lab works on a portfolio of different models, one for different workflow or for one for different domain. That's okay. And I just feel like the important thing is to the first person's question, if you're doing a private benchmark, being open about how you created the benchmark, how your systems work, so it's not a black box. And the person doing the private benchmark has to earn the credibility of the research community and be as open as they can be about the box that's generating the data. The only thing you don't want to leak is what's inside the box, because then you've gone away from the public benchmarks.
Thank you. Hi, my name's Morgan. I'm from Harvard Medical School, and I'm interested in healthcare benchmarks, especially around mental health. My question is about qualitative evaluations, which could be anything from what does good code documentation look like to what's a helpful way of interacting with a patient. How do you design automated kind of qualitative evaluations while mitigating the biases and blind spots and limitations of language models that you might use to do those evaluations?
Yeah, great question. Like for these qualitative assessments, that's the challenge when we move away from code and math, which can be automatically verified. Again, one really good feedback I got is like being more open. As we build these private evaluations, we actually share our way of doing this. So we will do that. The way we do that is we have a human in the loop verifier that is helping us make these evaluations. It's a human expert that's continuously training an agent to do these do these verifications. So we're internally building a code review agent at Turing, and doing that code review before you merge a pull request is also another case like the one that you're describing, where it's qualitative because the human reviewer might reject a pull request when maybe the coding style is not followed, maybe there was a security loophole in there that the person missed. It's not as easy as just checking if test cases pass. And even in your domain, like if it's qualitative, the way we think about it is you need two elements. You need an expert human and an LLM as a judge. Initially, a lot of the stuff is human eval, where the expert human might be doing it if the LLM is not good enough. But as the LLM is generating an output, if the human is overriding the result of the LLM, that creates a data set to further fine-tune this LLM. So we want to create these fuzzy verifiers to do these qualitative checks really quickly. It's a trade-off between precision and scalability. Obviously, you could do human evals all the time, but that's going to be costly. But maybe it's okay to have something that's 80% as good, but like 20% of the cost, and can rapidly keep getting better. It's again one of those beautiful things where the AI is making the job of the human better, and the human is improving the AI at the same time, right? Like humans and AI in like a nice self-improvement loop together. So that would be our approach. But the important thing is to have folks like you contribute to creating these benchmarks. Like we need like domain experts who actually do those workflows. And
hey, I'm George. I work on fine-tuning, and I've stumbled across a problem that some of them already described. That I fine-tune a model, and if I want to check its performance on public benchmarks, it's already saturated. It's really hard to find really like a good benchmark that you can show the quality improvement after the fine-tuning. So the question is, what advice can you give for like service developers as ours, and like for model developers as well, to consistently get some quality improvements, and more specifically, where to find the data that can be unique? So one hint is probably synthetic data, but if you have any ideas how to generate that, maybe you can participate in that as well by using your private data and generating like easy subset by using synthetic data generation, which can be unique all the time, to kind of provide some data that anyone can use for the evaluation to actually get some boost up to that.
yeah. So, and I'm curious, you said you're working on benchmarks. Like, which area do you focus on?
We focus mostly on like verifiable benchmarks. Like I do LLM as a judge, but we also have some academic benchmarks.
So like coding, like when you said verifiable, like which domain are you focused
we have coding math, and for LLM judges, like simple like preference, like helpfulness, reliability, answer, like this type of stuff, truthfulness.
Great. Yeah, I mean, step one is you've already identified the problem. Current benchmarks are getting saturated. You have to create your own, or let's collaborate together to see if you want to help us with the really hard benchmarks that we are creating for coding and math. We could work together. Step one is to like make sure that the benchmark that you're creating breaks all the models and agents with some margin. And by that I mean, when we are creating this harder than SweBench data set, we do pass at n, where n is 10. So in 10 tries, the model can, like in 10 different sort of tries, I believe like our threshold is like 80%. It has to fail 80% of the time, so that like it doesn't. We want to pick these problems that will stay broken for a while, and we also exercise some human judgment in what type of problems we focus on so that it'll stay broken for a while, like in terms of the failure modes. Like in SweBench, for example, we are looking at patches that are very large. And if they don't have test cases, we write test cases for it, right? Most of SweBench includes edits of like 7 lines. Not to say that smaller diff edits are not hard, but we made the decision, let's pick stuff that's like 50 or more, where it's the patch requires you editing things in different files in like a very large code base. So we'd pick cases that kind of further amp up the complexity. And we also are very choosy about what types of problems we will pick. For example, in the multimodal benchmark, if there are problems in extracting information from the image and then some downstream math reasoning stuff, we want to make sure that the area where we extracted like relevant context from the image, we really want problems there, not in the simple math stuff that you have to do later, like that. So exercising some judgment in like making sure that it's hard, I think is helpful. Hard, pass it in, and make sure that not just the models break, but the agents break, so that you pick stuff that stays hard for a while.
Yeah, but the question is how to, the way you're describing this is really a lot of work, right? So you just have to evaluating and finding the really quality data, but how to, if you focus on the other side, on fine-tuning, how to find some open data or generate yourself, or like maybe some creative ways to combine multiple benchmarks or whatever to get the results of fine-tuning.
Yeah, I'll have to think more about that. I'm not sure I know of any easy ways to do it. I'll have to think more. A great question. I'll have to think more about that. I feel like the challenge is it's very hard to, the public data is all kind of used up for the most part. And the reason most of the labs work with us is because all the models have seen the internet and, Common Crawl, C4, GitHub archive. They've probably seen some of the benchmarks too. So it's kind of really hard to do that well. Yeah, thanks. Great. It's really great meeting you all, and our team and I will be just outside the conference hall if you want to chat with us or see some of the data samples or collaborate on some of the stuff that I just spoke about. Thank you.